So activity 1.12, we're given the temperature of a potato that's been placed in the oven T minutes after it's been put in the oven. And we're going to estimate the derivative at some points. So A asks us to estimate the derivative at 30. So we're going to estimate f prime of 30 using a central difference quotient. Now remember, this is just an average rate of change. We're just going to use points on both sides. So 296 minus 180.5 over our change in input, 45 minus 15. So calculating that, we get 3.85. Now we're in a context, so there are units. This is in degrees per minute, and it's positive. So this tells us that the temperature at 30 minutes is going up by about 3.85 degrees per minute. B asks us to do something similar, except we're going to be finding it at 60. We're going to do the same thing. So we're going to use this point and this point. So 342.8 minus 296 are our temperatures. And again, our change in time is going to be 30 minutes. So this time we get 1.56 degrees per minute. Now we're going to be able to use this information to answer part C. They want to know, what do we think is larger, f prime at 75 minutes or f prime at 90 minutes? Well, look at the trend. Our derivative is going down. Well, that makes sense, because as the potato gets closer to the temperature of its surroundings, its temperature is going to increase less quickly. So we would expect f prime of 75 to be larger because the potato still has more room to heat up. As it gets closer to the oven temperature, it's going to heat up less quickly. D. Suppose that we're given that at 64 minutes, the temperature is 330.28 degrees, and we're given that the rate that it's heating up at 64 minutes is 1.341 degrees per minute. So we're going to use this information to estimate what we'd expect the temperature to be at 65 minutes. What we're going to do is, well, we know it's going up by 1.341 degrees per minute, and we know its temperature at 64 minutes, so we're going to take its temperature, the 30.28, and we know that for the next minute it's going to go up by about 1.341 degrees. So we're going to add that on to get our estimate. And again, this is just using a derivative to estimate. It's going to be around 331.621 degrees Fahrenheit based on our estimate. They ask us to do the same thing at 66. Well, we're going to use the same method because really we only know the derivative right now at 64. That's our most accurate derivative. We know it's going to be a little smaller than 1.341 because of what we said in part C, but it still will give us a pretty accurate estimate. So we're going to take what we found for 65 minutes, and we're going to add what we expect it to go up by roughly for the next minute. So that gives us about 332.962 degrees Fahrenheit. Again, we would expect it to be a little lower than this because we know that the rate of change is probably going to be a little smaller than 1.341, but we're just trying to get an estimate, an idea of what it is. For part E, we're asked to write a couple of sentences. So part E, what's happening is the temperature of the potato is increasing, and it's increasing the whole time over the 90 minutes. But notice what's happening with the derivative. The derivative is decreasing. So we could say that the temperature is increasing at a decreasing rate.